Gary, Gareth, and I, and are all definitely going to the NASA Citizen Science Conference next week. So we
Oh,
have a ham side display that Gary is working very hard on right now, and that will be Wednesday afternoon. So Gary, thank you for sending that email. I will make sure I am there in time for that. I'm planning on leaving Scranton, in the morning. So we have that. There's going to be some talk of this eclipse results as well. So we're trying to get ready for that. I think that's the big announcement on our side. Well, the other announcement is we're working on putting together a Hamside newsletter. So that's been really driven by Ed Fcheck and Mary Lou West, and so that is almost ready. The first edition is almost ready. We're hoping to have it ready for the NASA Citizen Science Group next week. And the last announcement I have right now is that last Thursday, Gwen Griffiths gave a very excellent presentation on the analysis of Whisper Demon Grape data received at my house during the eclipse. And that presentation was recorded and is available on the Hamsci Science Telecon YouTube channel. I will put that link in the chat. If you haven't had a chance to watch it, I think it's very worthwhile to watch. So back to Net.
Okay.
further, I think Gwen has offered to join this call and speak a little bit more on that presentation as well. So.
Sure.
Yeah, I think it's very worthwhile. Gwen has some very insightful comments. Okay. There, I just put a link to that recording in the chat.
Okay. Does anyone else have any other announcements? Okay. Any other new business discussion type things? We got for later. We'll go through the list first. At the moment, we've just got ray trace updates. Okay. Start from the top. Is Kong on?
Yes, I am.
Do you have any updates?
Nothing significant this week. I'm still working on the code to convert the legacy CSVs into HURF so that we can, at the very least, upload the data from the important dates such as the eclipse and the geomagnetic storms. Yeah, besides that, nothing else from me.
Cool. I guess we don't have any other further questions, comments, concerns on that. We had a good discussion on it before. Okay. Is Bill Engelke on?
Yeah, I'm here.
Do you have any updates on the University of Alabama server or the moving
Yeah. Yeah, I can give a report on attempting to calibrate the Grape 1 DRF system. Let me share screen here. Pick the right one to share. All right. Bob, W1XP used a signal generator to input some signals of known strength into the Grape 1 DRF. And it looks like here we have minus 45 dBm, that is 1.25 millivolts RMS, gives a reading of 0.6 coming out of the sound card. And then here are a couple more levels showing minus 55 dBm and minus 65 dBm. So using that data, I was able to come up with a formula for calculating or converting these numbers first from the sound card into volts RMS and then from there into dBm. So finally, what I went through and applied these formulas to Bob's test data. And so here it is, and it matches very well. Once you get down below about minus 85, it seems to be just noise. I think that's the limit of its sensitivity on the lower end. And so this should be helpful to Gwen Griffiths, who is trying to actually do some calibrated work using the data. So now one thing about this that is a little bit disconcerting to me, and well, first of all, this is valid only for the Grape 1 DRF. The numbers coming out of the ADD converter for the Grape 2 and the Whisper Demon system that's RX888 based are completely different. So I'll have to do separate calibrations for those. And then I'll have to figure out, I'll have to know what instrument I'm working with to produce this chart, which is quite doable. So one thing about this that I don't like is that if you use this to run on a typical plot for a given day, it will, okay, see if I can get the right one here. Here is the output in dBm. Now, dBm is a logarithmic scale. And so you're looking at the log of the values here. And if you look at that same one using, let me see if I can find it now. This is from last night. Shoot. Just a second here. Okay, here. This is last night's chart from KC4LE. And you can see all this nice looking variation. But when you look at that in dBm, now compare here, all of this, because it's a logarithmic scale, all this gets compressed as the signal levels get higher. So I don't know what to make of this. I've sent a discussion of this to Bob, as well as to Nathaniel and to Gwen. And see, now obviously it's possible to make this plotter do anything you want. It's just that what we're looking at here is the plots that are automatically created for every station every day. Now, clearly it's possible to download one of these observations and apply this program and adjust it to produce output that looks like what you need. So let's see how this fairly large excursion here is compressed into this tiny little pip here. So not sure what to make of this, as to whether doing this is helpful or not. Of course, you can always plot it, put out two strip charts, one for one with in dBm and the other one in just in uncalibrated units. So we'll have to just get some feedback from folks about that. I just wanted to let you know we're working on that. Also adding grid lines. There was supposed to be grid lines in all of them, but somehow something's in the wrong place in the loop. And so it's not getting, but I do have a fix for that. So that all of the charts will have grid lines. That's something Mary Lou asked for. So anyway, that's my report. Back to Ned.
Okay.
I have some questions and comments. So first of all, Bill, thank you so much for doing that. I think that looks really good. Second, I don't have a particular feedback, exactly what the best way to handle that is. Is there maybe, do you know, or maybe there's someone on the call who has significant experience doing documentation of receiver testing? Because it seems like this work that you're doing is very important, and we need it to be documented properly. And if we have people who have done that sort of thing, maybe they can help you.
One thing I would suggest is look up papers by Ulrich Rode.
Mm.
He likes to write about that sort of thing. So that might give you some help as to standard formats.
What is Ulrich's
He
last
actually
name again?
Rhoda, Rhode, like Rhoda and Schwartz.
Yeah, it's,
He
I
has
think
a
he's
really
son of the Rode and Schwartz. But he's very active ham and very much into receiver design.
he has a really nice textbook that he wrote about software-defined receivers. I have a copy of it in my closet.
The Monday night team might be able to help as well. I'm also interested to see what feedback we get from Gwyn, because he was the one who really asked for this. By the way,
Yeah.
tomorrow I have a meeting with a Telecon with the student programming team here, and we are going to have a look at what it's going to take to provide that API that Gwyn has asked.
Okay.
So
yeah, I think that's a very important thing, and that's actually that's essentially one of my requests too. I was hoping the happy approach would basically answer that, but maybe what Gwyn is asking for, just a very simple approach, maybe that's the way to do it for now.
I tend to think that, because doing a happy server is quite a project because of the display requirements.
Okay.
But maybe it's not so difficult to provide the API that just pushes files upon request.
And that would be, I
Yeah.
know for me, that would be immediately useful, because for me and other people who are literate in Python scripting and other language scripting, just having that API will give us access to whatever data we need,
Yeah.
just the way we want it. So yeah, I think that would be great.
Yeah, it should be possible to do them both, but we'll see if we can get this one first, and then
Yeah.
as a gap measure. So
Yeah. Do you have a plan for once you get all this characterization done, do we have a plan for documenting all of this?
well,
Because I think so maybe I'll rephrase that. Once you get this done, maybe you can hand it over to Gary, who can work on getting it onto the website, so we have a reference to where it needs to go, because I think this is a really important thing, and we need it documented on the website.
Yeah,
Yeah.
and any further guidance you have as to what wants to go in that documentation, we most welcome.
Okay. I guess start with Gwen and also with the Monday night group, and then we can go from there.
Yeah, all right.
I mean, if we had to, we could also poll the 1,200 or 1,300 people on our Google group too. There may be some people who've done this sort of thing.
I'm sure the Monday night group would also have some useful input.
Yeah, I agree. Thanks, Bill. That's really nice.
Yeah, it's coming along.
Okay. Very cool. Rob Robinette, any updates on the Grape antenna project or Whisper Grape update? If you're here. Nope. Wait. Yes. Rob? Okay, I guess we'll move on. Oh. Does anyone have any other discussion to add? Zaid, I guess you can take it away with your ray trace updates. Is my audio broken?
No, I hear you
Oh,
fine.
we hear you.
Okay. I thought I saw Rob Robinette on the call.
I just
But-
look, I don't see him now.
You can do your ray trace updates if you'd like, Zaid.
Rob is on. Must have stepped away.
Yep, okay. Does anyone else have anything else they'd like to discuss?
You know,
report.
go ahead, Bill.
I can report on the 5 refurbished Grape 1 DRF systems there that Bob and I are working on. Bob wasn't able to join today, but we finished reconfiguring and testing all 5 systems, and they're all working, and they've all passed their tests, and they should go out in the mail hopefully by the weekend, but if not, by early next week. And so those 5 new users should be receiving them next week.
Did you get past the one disk drive power supply problem, or we're going to let the users supply their own? We can go either way.
I believe you sent mail to Bob saying use one of the other stations' power supply for the hard disk, which we did, and because that station has its own 12-volt supply.
Right, exactly. Okay, great. Glad you got that
Oh.
message. Thank you.
Yeah, we just substituted that one. Trying to convince Bob to take apart the 12-volt supply that's faulty and see what's wrong. We'll see. We'll see what he does.
You'll need tiny little fingers to do that, I'm sure.
Yeah. Probably have to depot it or something. Anyway, that's it for me.
Gary, one question about that.
Sure.
On the new units going out, do you want us to run that alongside the Grape One FL Digi or replace it?
Well, I guess at one time we very much wanted to run them side by side so we could kind of verify the similarity of the results. But I guess I'd rather throw that question over to Rachel, who's one of the people looking at the data, what she'd prefer.
What was the question again? Sorry.
The question is on the new units going out. Shall we replace the legacy Grape One FL Digi, or try to get them running side by side?
There are still some people who use the legacy data. Christina Collins is using it.
May I suggest, so these are brand new stations that haven't been running before?
They have been running, but they were returned by users who I think got Grape 2 systems.
Okay, so are these going to new locations or are they going back to the original location?
They're going to new locations.
Okay, if they're going to new locations, they should be running digital RF.
Right,
Yeah.
right. Hetzel's question is he's got an original Grape FL1 Digi that he built and has on the air.
Yes.
When we sent him a Grape 1 DRF because we wanted to upgrade him, his question is, does he keep the FL Digi unit running or can he put that one in a box and repurpose his components, I guess?
If he's able to keep it running, I think there's a benefit to that.
Yeah, it's no problem to keep it running. It was just a question.
Yeah. Yes. If you have been running your Grape FL Digi in the past and you're able to continue running it, yes, please keep running it. There are some long-term studies that are making use of that original Grape FL Digi data that we're not ready to phase those out just yet.
Along that line, then, to not corrupt the data, should then I not share that antenna signal and use a whole separate parallel system for the DRF?
Are you capable of doing that?
Yeah, I just have to put up another antenna.
Yeah,
Versus-
so if it's not a hardship for you, then yeah, that would probably be wonderful.
Yeah, my wife won't like another antenna in the backyard, but if
I don't want to do anything.
If you don't tell her, I won't.
I don't want to create any family problems. So,
May I suggest?
so
She's
I would
not on
say
the Zoom call, so I think we're good.
Well, I'll just say that from a science perspective, and for that other study, keeping the FL Digi system running the way you had it is the best thing for that particular study.
Okay.
If doing that and running the new system is not feasible or difficult, then switching over to the new system, everything will be going in that direction.
No, it should be fine. I already got 3 or 4 other
Okay.
antennas. I got a egg beater and 2 HF
Right.
antennas, and yeah.
May
Right.
I,
Don't tell my HOA either.
may I add that you can use the same antenna and you can use the same grape card for both of them and run 2 pies with one version running on one and one version running on the other, sharing the audio, which is the way I have it.
That's
running it-
probably a good solution.
and have been running it that way for years.
Oh, okay.
Why don't you do that? And then just make a note when you make a change to your station, keep a log of when you made the changes to station. And that way, if there are any questions when we're looking at the data, we can go back to your log and be like, oh, you changed this on that date. And then we're all good.
Okay. George,
that's
would you
it.
send me the details about how you have yours set up so I can do it properly?
That's so I can send you a couple diagrams. I'll have to dig them off my hard drive. I'll send them to you.
Great. Thanks so much.
Okay. Any other questions, comments, or concerns on that? Yeah, I will say that for Zelda, Gareth Perry said 10 a.m.s would work on Monday, so we'll probably target that.
Okay, sounds great.
I'm gonna try one more time because I see Rob Robinette on the call.
So then
Yeah.
that way, what we're going to do, we're going to make Mondays at 10 a.m. That's going to be the goal of that meeting is going to be science. So we're going to try to keep it so that all we do is talk about things towards getting like science papers and results out. And then this will be more of an engineering meeting.
Cool beans.
Well, did we get to my section? I'm sorry, I was distracted.
We're back there now.
Okay. I do have just an update. Jonathan, on Monday evening, Jonathan pointed out a problem with these unbalanced receive antennas, that he believes that the use of the antenna like the DX engineering will introduce ground loops into the ELF antenna system. He, based upon I think his experience at your place, Nathaniel, where there was a ground connected initially to the shortwave system that had to be removed. And I don't know, I don't recall the details as Jonathan described it, but he expressed great concern that the shortwave.
Well, there was something different going on there. We actually had a copper ground wire separately running from my house out to the receive antenna location that was running parallel to his system. And I don't know that doing this will cause the same problem.
I think it needs to be tested. We don't have to go into the details here, but I think that your site is actually, we don't have, Michael doesn't have an ELF receive system at his antenna test site. And so, so he can't establish the performance, the potential for interference. So I think we're going to need to do some testing at your place.
Okay, and that should be relatively easy for me to do because I already have all the coax run out to the location for it. So all I have to do is get one of those antennas, and then we just have to assemble it, put it together, and we're gonna have to borrow my friend Declan's post hole digger, and he's always trying to have me store his post hole digger anyway. And then we just put that in the ground. But I've got all the coax running right near there, so I can talk to Majid about ordering. We can order one of those antennas. We can set it up at my house, and then we can run it right alongside Jonathan's system.
Yeah.
So yeah,
Good.
we can do that.
Okay, well, that was my major contribution for this week. So,
And
the upshot is that grounding, how it's grounded is important, and we just need to address that.
All right, and that's the same. That's the same antenna that is that we specified in the grant, right?
yes, it's the DX engineering probe. Yeah, I don't know the part number, but
Nathaniel.
Okay, great, thank you.
Yeah, so the upshot is that you have to be very careful about how it's grounded. If you're looking to receive things down in the LF, VLF range. And the best practice is to ground it at the antenna and then choke the feed line and power. isolate it or choke it otherwise.
Yeah, Nathaniel, you don't have a Kiwi, do you?
I do have a Kiwi.
Oh,
I just
good. Okay, we need
yes.
to really understand the whole noise spectrum
Mhm.
for the antenna system. The Kiwi's display is just vastly superior to the K9Q spectrum display.
Yes, I've
So
got a Kiwi sitting right there.
okay, so do you have the feed line coming in from your antenna? Can you put it into a splitter and one half goes to the Kiwi, the other to the
Very
triple?
easily, yes.
Okay, well, would you set that up and let me know when your Kiwi's online, and then I can access it.
Yeah, so the first thing, I've got a few steps here. First thing I have to do is get the new grant turned on, get a fund number for that, which will take a day or so. And then the next step I have to do is order the antenna. And then the next, so there's a couple. Well, I'll start this chain of events going.
Good. Okay, that's my point. Back a bunch of other stuff going on, but nothing that's relevant to this group. So back to you guys.
Okay. Any other questions, comments, or concerns? Okay. Kamal, are you still around? You are muted. Kamal?
Okay, yeah.
Yeah.
One moment.
All yours.
Yes, yeah.
Recording in progress.
Just was hanging because I'm using MATLAB, so it. Okay, can you see my screen right now?
Yeah.
Okay. Can you see it? Okay. Can you see it right now?
I can see it, Jamal.
Yeah, that's fine. Okay, so my task as a part of the research Dr. Nathaniel and I am going to deliver. Actually, we are going to regenerate successful receptions from transmitters to receivers on a certain date. Based on April 8, 2001, because the ionospheric behavior, as Dr. Nathaniel recommended, that it's going to repeat each 11 years. So, I'm doing some regenerations at certain frequencies, which are 5 and 10 and 15 megahertz from specific points, from WWV Colorado to Spring Brook at Scranton and K6 KPH at California. So our simulations are going to be to go through these transmission receptions and also to obtain the total absorption loss profile for each transmission. And this point takes a lot of effort and is still going through. Let's start with the first one, which is from WWV to Spring Brook. Special thanks to the giants I'm working with. W3OSR. Some challenges due to farlap and the model. I'm calculating the model we are going to use, and actually, I would like to say that I have found that within the function itself, I have found that the IRR model not 2001, it's IRR 2020. That's a point that raised my concern to give more elaborations. And also in the papers cited by Dr. Cervera, I found it IRI 2014, and that's a point to be raised and to be looked on back on later. The bearing process, the bearing calculation wasn't that straightforward at all due to the ellipsoidal nature. So I wrote a code at MATLAB, and actually I wasn't confident about it at all, so that I was testing it multiple times. So I operated at some well-known points and I tried to use the GPS visualizer, and it works fine now. So let's have our first point from WWV to Spring Brook, Pennsylvania. I was trying as much as I can to check my results using a visualizer, and I found the GPS visualizer starting from the latitudes, longitudes from the transmitter and to the receiver, and to find the distances. And here I'm getting my reference, the initial bearing and the distance to be calculated. Both are working fine with MATLAB right now. Yeah, and we can find that the distance between them are 266 kilometers, and here, as you can see, 2466 kilometers. The bearing itself, actually, it was here, yeah, 78.6, which is here 78.6, so it works fine. And actually, the imagery visualizing works fine from WWV to Spring Brook. So going to the results, that's getting crazy because when we give a look at it at last meeting, we thought it's 6 hops, but actually they are only 2 hops, and I am intending to give this result because I've been modifying the top of the figure to say that we are going to give only 2 hops. They are not 6. Actually, it's a hop. This is a hop, another hop, and it stops at this point. So this variable at the MATLAB code, it tells the simulator to stop after only 2 hops. So what are those ones? They are the extension of the other rays. So in order to get a clearer vision, I just opened the gate for a very large number, which is 15 hops. For sure, they will not reach 15 hops, and then manually tracing it by eye, and that's very exhaustive kind of search. And I find a future point to discuss, and I would like to have your opinion. So let's have it by the naked eye. If I am standing here at that receiver and transmitting from WWV to Spring Brook, so which ray I am interested in right now? So looking forward at this blue arrow, we can see this ray. Okay, this ray isn't the perfect one, but it's the nearest curve to our receiver. Although it gives a rebound at the ground and gives a small kind of hop. This one can be considered as one. So I just picked up this one. How can we do it? Till the moment I'm getting them manually by just tracing it. So working on this one and getting back to the receiver, I have found it manually to be at 6 degrees. Angle of elevation of 6 degrees, which is mean 0, 2, 4, and 6. Then I'm going to pick only this ray to study and to get the profile of it. So jumping to the next one. 15 hops gets the seem very complicated, but actually I give it a try, and yes, and I found it okay. There is no ray other than that one of the 6 degrees due to the receiver. I traced that ray in those 15 hops. That's great, right? That one was close, and after this tiring exhaustion, I found that the 60-degree elevation that was so close, as if you are playing football. So let's try the other one, and actually give me that it is the 8 degrees elevation. So choosing the elevation angle to be 8 degrees at 5 megahertz give me that kind of ray. So that's working fine. By the way, I think it might be from 6 to 8. It means at 7 degrees, for example, might give a better result. So it's a heuristic search one. So jumping to the analysis of the parameters we are working on. So I'm getting this kind of workspace at MATLAB and giving an eye and letting an eye on the total absorption one and the deviative absorption one. I found that only those 2 kind of absorptions. So before getting these results, I just wanted to make some checks I just wanted to discuss with you that the distance, for example, from WWV to Springbrook is 2466, and actually the ground range is 24820. And actually this makes sense because actually that ground range is the geodetic one, and this is the distance, the normal planar distance, and this makes sense. So
Yeah, that
it
looks
gives
good.
me the intuition that, yeah, it gives me intuition that things are going fine. So I was investigating those kind two absorptions, total absorption and the deviative absorption. I get back to the documentation by Dr. Cervera, and I found it very useful, very complicated, and needs much more efforts. But to make long things short, the total absorption is based on the integration of the complex part of the refractive index based on a very complex formula. I'm just getting to digest it much more than this, but it has a mathematical formula. The deviated absorption, actually it was based on neglecting some parameters, neglecting the geomagnetic effect and another variable. And he was mentioning that this parameter, in case of our neglections, is greater than the ordinary polarization, and less than the extraordinary one. So if you are going to insert those two assumptions to be I mean to calculate and to count on the geomagnetic effect, we will get the right values concerning this deviative absorption. So I traced that total absorption because that one is based on the modeling. So I just look at it. If you can see, it's very small in font at the bottom. Ray path data. This is a structure in MATLAB. Ray path data, and actually it contains all the 40 rays and etc. Just picking one ray makes things much easier. So I picked up that parameter, which is called absorption, and I traced it through all the samples. And I found very strange thing. What is it? At the sample of 222, the 222 sample, after this, the total absorption becomes constant. So I was wondering why this is going to happen. And actually, I spent some time doing the wrong analysis till I discovered that there is another parameter that gives much more sense to be linked to this number. I mean, this 222 is not the ground range. It's not the distance. It's nothing. It's just the sample number. Okay, we are going to have samples from the transmitter to the receiver based on the range and the grids and etc. So this is the sample. This is the 222 sample. Okay, so what is the x-axis to give you the intuition is? And after some work around, I have found it to be the geometric path length, the physical path length. But and actually not by sense, not by heart, by just doing some investigations. Okay, going for the next slide. Here we go. Come on. Yeah. Here is that I was going to mention that back into the documentation by Dr. Cervera, they obtained that absorption by integrating the refractive index, the complex one, components based on this paper, Dr. Pederick and Cervera, and I get back to it to get exploration what is the formula looks like. And the other paper, Zaudi et al., probably al is Dr. Cervera, uses the complex refractive index with no magnetic field. This is the assumption. That's why they were specifying the effective collision frequency. I mean, if you are going to give no magnetic field in the model, you should specify what is the effective collision frequency in the grid. So I'm getting more hands on those papers, foundational one. So then back at 5 megahertz, we can have a successful reception and we'll know the absorption, how much absorption are going to have in decibels. So the second one, which is 10 megahertz as requested. So at 10 megahertz, I found this one. Again, I'm going to pick that ray. So this will be that one at the bottom right. Yeah, it's the 10 degree. That makes sense. As much as you increase the frequency, you're going to get the higher elevation one to get the same tracking to the receiver. So choosing the array and getting more analysis, the same procedure is going to it. We are getting focus on the absorption and the deviative absorption. Here is the point. Actually, I just wanted to know how does it calculate the absorption. So I just went through the plotting that parameter, plotting the absorption, and I found it getting that orange behavior. That was very strange because I don't know which x-axis are we going to go through, right? So I don't know what does it mean. For example, the point that was very interesting for me, why at the sample 222 is going to get that saturation, or even much further than this, but why it's going to be saturated? To answer this question, I need to know what is x-axis. It's sample number x. What is sample number x? So I just went through the next slide to get trying with most of those parameters to find the x-axis to be, yes, and here is the point that I was going to mention. It's found in the repath data if someone wants to look at this point. Here is one. Here is that one. Sorry, my voice is very loud. Okay, so how can I know that the x-axis is going to be the ground geodetic range? I just plotted this ground range, the parameter itself, with the sample size. So I found it to be 45 degrees. 45 degrees, and this means that they are both the same parameter. Okay, then the x-axis here is the ground geodetic range. So, and that makes sense. So getting back to the grids, oh, it makes sense. Okay, then after the 1990 kilometers, it gets saturated, and this gives us intuition for further work. We can go for certain
So
distance and see.
it probably, I think, Jamal,
Yeah.
I think
Yes,
it does it get saturated when you generated your ionosphere? Did you generate it only out to 2,000 kilometers?
No.
What did you?
I generated maximum distance. I generated
What's
at the
that?
maximum
Well,
distance. I
there's
generated.
something serious, Gamal, there's something seriously wrong here. Total absorption is not a half a dB. It's going to be on the order of 100 dB.
Total absorption. Okay, let's give some more eyes on it. Dr. David, the eagle eye. Okay, total absorption is in 100 dBs, but back into the documentation, I found it to be dBs, so I can I should give some efforts in it. Okay, perhaps.
I just want to say first, Jamal, like this is a very impressive presentation. Like you have done a lot of work between when I talked to you about this like 2 weeks ago and now. So any comments we're giving you, I just want you to know that like I totally recognize how much work went into this, and I think this is going in a very good direction.
Yes.
So
yeah.
So
Sorry.
so yeah, let's hear what David had to say, because I think he's right.
Yes, sure.
The total absorption should be much greater than a half a dB, but I think trying to figure out why that is.
Okay, sure.
And my suspicion, the reason I think it's saturating, if you were to if you looked in the code again or your run, I'm gonna bet that you set the ionosphere only to go out to 2,000 kilometers, or the ray tracing to only go out to 2,000 kilometers.
No, I was setting it to be, first of all, I detect the transmitter and receiver, then I calculate the maximum distance based on the geodetic model. Then I take this parameter, which is maximum distance, the geodetic distance between transmitter and receiver, to be used to generate the ionospheric model.
Okay.
So
Why don't I let you? We can talk about that more later. Let's keep having the discussion with David, because I have to drop off right at 11 a.m. to go to another telecon. But I think David is going to give you some good places to go next. So keep talking with David.
As always, Dr. David. Thank you, Dr. David. Okay. I'm just getting some conclusions. The same environment at 15 megahertz, no reception. At that point, I need to discuss it. Okay, no reception at 15 megahertz, and that's so weird. Then, okay, previously from WWV to scan-on, then from WWV to K6 KPH. Some info, some spices, and some visualizations. Yes, the same procedure are going to be done. Getting that lots of rays, picking someone, actually, and doing at 10 megahertz no reception, or actually very weak reception. Then at 15 megahertz no reception at all. Okay, I just have some more, but I just clipped them to make us more focused today.
Yeah, that's a tremendous amount of work, Jamal.
Yeah.
Very impressive. So yeah, I think the next thing to do is to I do agree with you. Looking at some of your ray traces, when I looked at them again, it was very clear the ionosphere was calculated out past 2,000 kilometers ground range. So I'm not sure why it's saturating there, but it does look to me, just looking at how it saturates, like the first thing I'd look at is something where you have something in the code set to 2,000. But then after that, I think David is right. Why are those absorption values on the order of like a half instead of like 100 dB?
Okay. I just have an idea, but I'm afraid that all of you can call me a crazy man. I have found a solution how to get the exact ray, the angle of elevation without doing that manually.
Yeah.
Yes, I have an
Well,
idea.
the other thing we have to remember here is that again, this ray tracing, I mean, this is like one step better than making a cartoon or a comic strip. It's like, I mean, we're using a climatological ionosphere from 2001 here, and we're using, you know, and these rays, like to say that, oh, this is the exact value, you know, that's really tough. So we have to think about, we have to think about what that means in terms of when we say exact or not exact. So I think I'd avoid using the word the exact ray right now.
No, I mean, for me, for example, I'm doing the manual search for the ray to choose in order to all.
Okay.
Yes, I will pick this one. So pick this one can be done by an optimization problem. So I thought
Okay.
about two techniques. The first one is the fmincon in MATLAB, fmincon, and the second one is much more crazy. It's using particle swarm optimization.
Okay. Well, I think this is I'm gonna have to go, but I think this is the sort of thing that's gonna be really good to talk about in the Monday morning meetings with Joe Cuba and with Rachel and with Gareth and Kuldeep. Like I think I think you're off on a good path here. So keep working on it, and definitely keep looking at reasons why the absorption's so small.
Sure.
I'm gonna say 73. Anything else for me, Rachel, before I go?
You might.
Nope.
And starting recording.
There you go.
Beat me to it. Excellent. Well, good and good evening, everyone. Welcome to the Thursday, October 31st AM Science Zoom call. Today,
I think
we'll get right into it.
There you go. Someone's watching the Gwen Griffiths video. That's what it is. All right. Have a great day, everyone. I'll see some people at the 4 o'clock Telecon.